Okay, so let's talk about the solar system, and then I'll make another video to talk about gravity and the math involved in this module. I know lots of you were absent because of team pact and illness, so and I know the video job I did in class was bad. So hopefully these two videos will clear up any questions you have about the chapter and help you on the test. So the solar system that we live in, like if we have the sun here, has 4 inner planets, and they are terrestrial planets made of solid ground, and they are Mercury, goodness gracious, Venus, Earth, and Mars. Mercury, Venus, Earth, Mars. You need to memorize that. And then there is an asteroid belt, and then the 4 outer planets, they're gas giants, and they are Jason, Jupiter, Saturn, Uranus, and Neptune, and they all orbit the sun in an elliptical path that is nearly circular. They orbit the sun due to the sun's gravitational attraction to them, and they don't orbit perfectly in a circle because of perturbations which are caused by the gravitational forces between the planets and other massive bodies in the solar system. So every planet has a gravitational force between every other planet, causing the orbits to be a little bit different than just a circle. But the sun's gravity is the biggest, so it mostly controls their orbit, and other things can only cause small fluctuations. The obvious thing here is that Mercury, spatial skills, backward. Mercury receives the most insolation from the sun, incoming solar radiation, because it's the closest to the sun. But Mercury is not the hottest planet because it doesn't really have much of an atmosphere. Venus has an atmosphere of thick carbon dioxide, so it's the hottest planet, even though Mercury gets more insolation. So that's another interesting detail. The asteroid belt, if you watch the video with the physics teacher and the big round frame with the sheet of spandex, he put the mass in the center of that spandex sheet to kind of bend things in, and sent marbles and little balls orbiting in 2 directions. And those that were going in the preferred direction, some of them survived and continued to orbit, while some that were going the other direction experienced collisions and eventually weren't able to continue. So when it was all said and done, they were all going the same way. One of the hypotheses is that the asteroid belt used to be a planet and now is the debris from the destruction of that planet due to a collision. Perhaps it was going the other way. Let's say all the other planets go counterclockwise around the sun. Perhaps if this planet had been going clockwise, experienced a collision and was kind of weeded out. So we don't know for sure, but that's one hypothesis about the asteroid belt I thought was interesting. Let's see, asteroids still experience collisions, and if an asteroid, let's say here's the sun, let's say here's Earth, right? And we know Earth is orbiting around the sun, and say an asteroid is knocked from its orbit because of a collision, and it encounters Earth's orbit as it's pulled in by Earth's gravity. So here's the sun, and here's Earth. Let's say this line around is Earth's orbit around the sun. So let's say an asteroid passes through Earth's orbit, but not the place where Earth actually is. I'll make this one bigger because, of course, we all know the sun is much, 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 much bigger than Earth. So if it passes through Earth's orbit, an asteroid is now here we come, this asteroid, is now called a meteoroid. And if, instead of just passing through a section of Earth's orbit, it actually passes into Earth's atmosphere, then, as you know, it's called a meteor. And we talked about how meteors often burn up in Earth's atmosphere. Can you remember which part? And then, if a meteor actually survives to make landfall on Earth's surface, which is rare, then it's actually called a meteorite. So I don't know how to draw Earth's atmosphere. Of course, you know, is super thin compared to the size of the Earth. So if it actually makes landfall, then it is a meteorite. Okay, so that's the confusing and similar terminology. An asteroid that encounters Earth's orbit around the sun is a meteoroid. If it actually encounters Earth's atmosphere, it's a meteor, and if it actually makes landfall on Earth, it's a meteorite. So that's basically asteroids. The other thing that you need to know about heavenly body-wise is comets. So comets consist of a nucleus. And the nucleus of a comet is made of dust and dirt, and also some frozen substances such as water, ammonia, methane, and carbon dioxide. So it's all solid, and comet orbits around the sun just like Earth and the other planets, but instead of a nearly circular elliptical orbit, it has a very pronounced elliptical orbit. So let's say here's the sun, and here are the orbits of planets, right? Well, a comet has a super elliptical orbit. Not a nice circular orbit or almost circular like a planet, but a very pronounced elliptical orbit. So comets are just the nucleus that's completely solid and frozen throughout most of their orbit. And it's only when they approach the sun and receive larger amounts of insolation and heat that we see the other two parts of the comet, which are the coma and the tail. Okay, the coma and the tail. And they are formed when the heat of the sun causes the water, ammonia, carbon dioxide, and methane to go straight from frozen solid to a gas. It's called sublimation. So those substances that make up the nucleus sublimate, form the coma and the tail. The coma and the tail are actually receiving so much energy from the sun that they emit light, and they're very, very visible. And the tail of the comet always points away from the sun because the solar wind, which isn't really wind the way you think of it, it's radiation and particles, push the tail of the comet away from the sun, just like wind would push my hair in the direction that it's going. So the tail of the comet almost always points away from the sun. So there are short period comets. Short period comets tend to have orbits that go out to around where Jupiter is. That's the J for Jupiter. Short period comets are hypothesized to come from the Kuiper Belt, which is just beyond Neptune. And the Kuiper Belt was detected by the Hubble Space Telescope, and yet we've not observed one of the objects in the Kuiper Belt actually being knocked out of its orbit by a collision and becoming a comet, but that's the hypothesis of where these comets are coming from. And then they're trapped by the gravity of the sun and begin the elliptical orbit around the sun. Comets can only pass around the sun a certain number of times before they lose too much matter because it melts or sublimates off, and then they lose some of it each time. There was a comet last year, actually, that didn't survive its trip around the sun and fell apart. If it had, it would have been very visible in the night sky, and you guys would have seen it last year for a period of time in the night sky, which is really neat because I got to see the Hale-Bopp comet in 1997. It was around a few weeks, I think. Very memorable and huge and beautiful. You could see the coma and the tail stretching through the night sky night after night. It was very beautiful. But the Hale-Bopp comet is a long period comet. Its period is probably something like 3,000 years. Short period comets are less than 200-year period. They go out to about Jupiter. Long period comets are less than 5,000 years, and super long period comets are more than 5,000 years on average. Not much is known about those. Oh dear. Okay, still recording, that's good. So, anything else about comets that I didn't just tell you? Long period comets are hypothesized to come from a group of space objects called the Oort cloud, named for Jan Oort, a Dutch astronomer who hypothesized that it was out there past Pluto. The Oort cloud has not yet been observed, but since we confirmed the presence of the Kuiper belt, and it seems more and more likely that short period comets come from there past Neptune, that certainly is one piece of evidence that there's another cloud of matter, the Oort cloud, further away that is producing the long period comets. So one more thing that we don't know for sure about space, many of those things, right? So I'm going to stop this video and make a new one about gravity, and hopefully you will feel well prepared for the test.